So this is notes for 6.2. This is the cube root parent function in the transformations. So I already said that the parent function for the cubic function had a domain of all real numbers and a range of all real numbers. Same thing goes for cube root. So the symmetry was 180-degree rotational symmetry. And it's rotational about its inflection point. So its intercepts are 0, 0 for x and y. And the table from the cube, or for the cube root function, is switched from the cubic function. On the cubic, we had -2 cubed was -8, -1 cubed was -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So for the cube root, we say the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1, and the cube root of 8 is 2. So over here, -8, -2, 1, 1, 0, 0, 1, 1, 8, 2. So it looks just like the cube root fell over on its side. So then transformations. So this is rewrite the cube root equation based on the transformations, graph the function, and list the domain and range. So domain and range, all real numbers. I'm going to rewrite the function rule as an equation. So I need parentheses, x plus 3. The function here is the cube root. So the cube root of x plus 3 minus 2. So the same thing for b. I have -2 times the cube root of x plus 1. So the transformations for these, I went left 3 and down 2. This one, there was a reflection. There was a vertical stretch by 2, and it went up 1. So for these, I'm going to graph them by hand. So went left 3 and down 2. The inflection point would be at -3, -2. So it's going to look something like this. So then the next one, if it went up 1, the inflection point would be at 0, 1. So from there, it should be below and then come up, but since there's a reflection, it's going to be above and then come down. So something like that. So on the back, my equation is going to be 1/2 the cube root of x minus 1 minus 4. And then d is going to be negative cube root of x minus 4 plus 3. So transformations of a 1/2, so that's a vertical compression by a half. It went right 1 and down 4. So D, there's a reflection. It went right 4 and up 3. And of course, the domain and range is all real numbers. So here, if it went from 0, 0, right 1, down 4, it'd be at the point 1, negative 4. This one, right 4, up 3, it'd be at the point 4, 3. So we're gonna have some description problems. It says that the cube root function was transformed so that the inflection point is -2, 0. So that tells me it went left 2. There's a vertical compression by 1/4 and it was reflected over the x-axis. So I have the cube root of x plus 2, and then I'm multiplying by 1/4 and it's negative to show there's a reflection. So the next one, if it went from 0, 0 to 2, 5, it had to have gone right 2 and up 5. This next point should be 3, 6. So I know there's something weird happening. It should be increasing, but it's not. So there's a negative reflected. And I have some sort of stretch. So the difference in my y values would tell me what my stretch is. From 5 to 2, it went down -3. And the last one is pretty straightforward. You had a vertical stretch of 2. You went right 2 and up 3.